let's go on through chapter 17, and then next week y'all will have lab days to work on. You've got the final lab to do with the cabling without assistance, but the other requirement is before you can do the final lab, you gotta have completed the midterm lab. So make sure that's completed and then that you can do the final lab. And then y'all can work on other labs that you need to work on also, because there is one in 17 and such. So y'all can work on that next week too. Besides the fact that y'all can get into your other times to work on labs, to the ones that need to work on packet tracer and can work on it elsewhere, since it won't work on y'all's Chromebooks. So with 17, it is the last chapter. And so we do have class with those labs next week, Monday and Wednesday. And we do have class that following Monday, May 3rd. Your final exam will be available Saturday, May 1st through Tuesday, May 4th. And it's twice as long as your chapter test on it. So should be about twice as many questions that come out of the whole book out of the same test banks that your chapter test came out of. So make sure on those deadlines, okay? Any tests that need to be made up, any labs that need to be made up, all have to be completed by a week from this coming Monday. On May 3rd. I'm not going to accept after that. The other part is, if they're late, they are taking penalties on them. Like the syllabus is for 15 points a week. Okay? Remember lab final, which is your cabling final. That is a mandatory item. You have to do it. If you don't do it, it doesn't make any difference what your average in the class is. You fail the class. That's a CIST policy. Have to do that to pass the class. Likewise, you have to do the final exam. CIST requires that as a mandatory item too. Although each of those items in my class count as 10%, but they're mandatory items. Okay, so if your one's not done, it doesn't make any difference what your average is. You know what your grade is. Okay. Also attached with that on the final exam is that you do have to do course feedback at CIST too. At CIST, when you go take the final exam, if you haven't done the course feedback at CIST, it will make you do the course feedback first before it lets you do the final exam. They changed to that pattern a few years ago. There is also a course evaluation that you received a link to in your college email that I would encourage you to do that one also, but it's not required, but the school and I would like for you to do that, okay? And I will look at the results of that. Now, I don't see results by individual student. I just see what the class, how many people in the class responded. That's what the administration sees also. And I would encourage you to do that in both of your classes here, for both this class and for Ms. West's class, okay? Particularly, it's a number of multiple choice questions, and then there is some short answer ones, and I would definitely encourage you to do the short answer ones, asking where you can tell about things that need to be changed to improve the class, okay? Whether it be things you want that should be added in here, or things that you're wanting shouldn't be in here, or whatever, okay? If you would on that, because I do pay attention particularly to those. The other part on that is she and I will not see the results until after grades are due. So they don't release to us what the results are until after we've turned in grades. So you've got, I think, should be probably through the end of the week after next to do that, okay? I would encourage you to get it done by Monday of that week, but it does stay open for a couple of more days, then it closes, and then a day or so it gets released to us. I'm not sure if grades are due that a week from Friday, or if they're due that following Monday. Some different semesters, they do differently on that. And so I have to have grades in by, and my intentions is for me to turn them in by 10 o'clock that Friday morning. So that next week I can take off as I need to. Okay? Now, chapter 17 is going through and looking at setting up a network and you getting all the settings on the routers and switches, okay? So they're going to have you set up in this chapter that they're going through, that you're setting up a small business network, okay? And so a lot of what they're going to show you here in the chapter, we've actually talked about earlier on and that you've actually done the different commands. Now they're putting it all together where you can see here's how it all works together to run an actual network, okay? So they go through and they talk first about when you're choosing devices for that small network. Because remember, if it was a large network, you would get different devices for it, okay? Because you'd get much larger routers and switches, which are the type ones we've been working with. Speeds, you may get higher speeds for a large network, and so on. So there's some different things you would get, because Cisco sells different routers and switches for large to small, actually home networks, or actually used to sell home networks, but they spun that off. Linksys was originally a Cisco company till a few years ago, and then Cisco decided to get out of the home market. So, but that's still there. Now, if you're choosing those devices for the small network, one of the big things that you may well be considering is cost, as opposed to in a large network. If it's a large organization, and a lot of times cost is not quite as much of a consideration on it as in a small network. Because a small organization, usually money is a lot tighter, and that they don't want to spend as much. So cost is going to be a factor there as you look at the different equipment, so deciding which equipment would you get. Second thing they mention is to look at your speed and types of your ports and interfaces on the equipment. My suggestion to you, is usually to get as fast as you can get on those, and ideally go ahead and get the speed on your ports and interfaces at that, and that's going to keep you from having to replace them very much down the road. Now, the other thing is, as far as the speed of ports and interfaces, basically today, and been for a number of years, that's been just studied out, and that if you're going to go buy them, you ought to be getting the fastest, which is at the 1 gigabit speed, okay? But you'll see on them that they will work at normally at 10, 100, and 1,000 megabits, which gives you the gigabit speed for the top speed, okay? And they can work with the different ones. There is stuff supposed to be starting to come out now, but I have not seen it at this point that will run at faster speeds than that. But as far as a small organization, you're probably not looking at the faster speeds on those. Expandability, that would be an important one to consider. Because a small organization is one that is highly likely to grow. Your big organizations are not as likely to grow. If you talk to economic development people, they will tell you that if you've got a small industry, it's one that's going to produce more jobs over the next so many years than when you get a large industry. Initially, you get that huge number of jobs with the large industry, but they usually don't add on additional jobs over the next period of time. Where the small industry is very likely to start adding more jobs as they sell more of whatever it is they sell. So as you're setting this stuff up, definitely plan it for your expandability, because it's highly likely, even in a large organization, small organization, large organization, but small one particularly, that you're going to end up with more stuff needed connected to your network than you've got now. Even as we look here at the school and the room in here, hopefully they've got additional ports in here beyond what we're using to run all of these machines, so that when there's a need for some other things plugged into the network, it's there. Also, that the wireless network can support an increased number of devices too. It's exactly what the devices are that we're going to have in 5 years, I'm not exactly sure. But there's a good likelihood that we're going to have additional devices to hook up to the computer, to hook up to the network, that we may not even know about today. Okay? Or that you're sitting there and looking at as science fiction. And in 5 years discover it's not science fiction anymore. So definitely consider that. And then they said the other one is that as you're looking at these devices, the networking devices, consider their operating system features and then the services that they have. What all comes on that device. And your lower, smaller ones, like the Linksys ones, are very limited on what they can do. But for home use or just a small office, which quite often you'll see them reference as small office, home office, which you'll see abbreviated as SOHO. You may not be doing some of this stuff, like voice over IP. That might not be something you're doing, although a lot of people are doing voice over IP now. Because instead of doing your telephone service through telephone lines and through the telephone company, that you may well be doing it through cable or whatever, and then obviously lots have dropped any type of link line to it, but a lot have gone to voice over IP, and you've got a number of people that are using voice over IP that have no idea they're using voice over IP. All they knew was when the cable company came around, they had a real good bundle price for them. If they not only get the cable TV, but threw in the phone with it too, and that it was going to be cheaper than what they were paying for phone service for with the other, and don't really have a full understanding that it's going through the cable instead of going through phone lines anymore. So security is definitely more enhanced on the bigger devices too. DHCP actually is pretty much out there in all of your routers at this point now that you're using to direct on everything. So that even when you're sitting at home, that you're using DHCP there also. But my newspaper article I wrote night before last was about using ipconfig/renew and release, that when you get the problem of web pages keep timing out or some other problem, and you're going, it looks like it's my IP address is causing some kind of problem, but how to use those two commands to change your IP address or it actually may refresh it times. Then they talk about on the IP addressing for the small network and about how you may well be setting that one up within the network and what type of addressing you could do to it and how many, and in their case that they're talking about what these devices are, and they come up with a scheme where they've got a certain number of addresses available for each type of device. You know how the devices are, but they've allowed themselves a couple of more devices on it. Okay. That's strange. Show you a topology right above at the top of the page, and then they give you this example of an IP addressing scheme, and what they've just shown you at the top of the page won't work in that scheme. Because the top of the page has how many switches connected to that router that goes to the internet? 3. And then down there in their scheme, it's set up for a maximum of 2 switches. I don't know where the third switch goes to. So, although they show you the one they were showing the example off of on the next page, it didn't work out on how that was. The second thing is planning redundancy in there of multiple routes between your switches and machines and your routers, so that if something does go bad, you don't lose the whole network, okay? And that you've limited what your losses are. So you may well want to build redundancy in there, but in a small network, you may not be. Because again, that goes back to the first thing we mentioned, cost. So you put redundancy in there, you're running up your cost on it, okay? And like on the routers and switches that y'all have used there in Packet Tracer, that we just ordered 2 of the routers and 1 switch and then a wireless device. I think that's all that came in it, which was the same routers and switches like you've been using. And they are going to cost that bundle of, I guess, 4 devices on it, but it's going to cost us right at close to $3,000. Okay? Somewhere about $2,500. That's actually at a 60% discount off of Cisco's normal price. They give a big discount to academies. So that means that really, for people buying them regular businesses buying them, it would cost about double that. So y'all can see those things are not cheap. Okay? So those aren't $100 boxes or whatever, like you can go to Walmart and buy just a simple little small router. Okay? And they talk a little about traffic management, which is where quality of service comes in. Quality of service is just defining for us about how the traffic goes across the network. The next one, and that you can prioritize the different things in there. Interesting, they've changed on this one. They've got voice over IP as high priority on the network, and other places in their previous books, I've seen them put voice over IP as a lower priority and put some of the other stuff higher up on it. But they've got that because the reasoning they always gave in the other books was that on voice over IP, you could have some loss of packets, etc., across the network, and it wouldn't hurt the conversation. Because if there was just a piece of a word missing as it went across and 2 people were talking, they wouldn't even notice it. Well, other stuff is something that's not getting lost, you've got a major problem, okay, when you're sending data across. And they talk a little bit about different applications. So So they mentioned about your network applications briefly that you need to be aware of that need to be set up. So you've got things like email clients and web browsers, which just about every device all of your PCs, your phones, etc., that are connecting are definitely going to all use those. Obviously, your printer is not going to use those too, but most of your devices connected to your network are going to use those two items. So that's what your users are going to use. And you've also got things like printers attached on there that aren't. They mentioned about services. Make sure you've got services that you need running on it also. If they mention on a Windows PC, you can use Task Manager to see what the services are that are running on your machine. And about which protocols you should be using. And we kept talking about those throughout. And we just talked about those in the previous chapter, but just as a real brief look over again on some important ones that you need definitely running on your network. You definitely need HTTP, HTTPS. I doubt very seriously there's any networks out there today that are not got people going out onto the internet. Okay, and they may not be letting everybody go out on the internet, but they're definitely got users using the internet. Most likely everybody. They may limit them on what they can do on the internet, but they're going to be able to get to it. So you need to use both of those. Email server, pretty much the same thing. That's your major communications method in the corporations and for other purposes too. Now, you've got smaller instant communications where you're using things like texting and such out there too. But so they mentioned about you need the SMTP and the IMAP protocols running to take care of the email. And then they suggest that they're going also that you also need to be aware of what your different people's email addresses are, and that it's going to be in the form of the user at, and then whatever the name of your domain is. FTP server, that's used a lot out there. Not everybody's going to be using FTP, but you've got a lot of people using FTP to transfer the files. So obviously sitting there, you need FTP protocol, and you may well need the secure FTP also, of the two different types of that. Although I have not used either one of those secure FTPs. Okay. DHCP, today you basically need that. You could, on a small network, statically set up all your addressing, but I would recommend not. Use the DHCP server and let it assign the addresses to the machines. You don't have to worry about trying to remove which address is assigned to which machine. Okay. And then you need a DNS server so they can use domain names. And so obviously you need that, and then you'll need the DNS protocol on it also. The video, make sure you are going to need, if you're going to do join voice and video, whether it be voice over IP, your IP telephone, your video coming across on it, whatever, you are going to need a stronger infrastructure there. So you are going to need, that's where you definitely want to have the highest speed on your inside on your internet, and you need a decent speed going out to the outside world. Okay? And that you got to have plenty of bandwidth there for it to handle it, because it is going to use a good bit of bandwidth on both of those. I've already mentioned about scaling for growth. So as you design it, make sure you've allowed for growth in the future. And we talked about that on IP addresses also. As you design your addressing scheme, don't design it for just today. Allow growth on everything you've got in there. And Then they talk about that you may well need some protocol analyzers to be able to analyze your traffic across your network. That one you may or may not have on a small network, and it only be brought in and be used by whoever manages it for you or your outside consultant that you bring in when you're having problems. You may well not be getting some type of analyzer with a small network. Okay, but Wireshark, which didn't y'all use that earlier on, if I remember right, that Doug did something that used Wireshark for just an exercise, I believe, so to see how you can watch traffic and analyze packets and stuff. And that's purely a program you're running on top of the PC or whatever, so it's not something you've got separate, but you can get better things that actually are separate devices, okay? Then they talk about making sure how your employees are utilizing the network, what OSs they're using, what's their utilization of the CPU on their machine, because that's going to be a question of do you need to upgrade their CPUs at points, their RAM utilization, how much are they using their drive, and do they need a larger drive, and so on. A guy I was talking to yesterday when I was at Backpack Blessings packing food for kids in Walker County to take home on the weekend. A guy was talking to me about that he bought an older 10 or 12-year-old PC, I think it was, maybe a little bit older, actually, a little bit older, 15 years, and he said it was slow as anything. But he got it dirt cheap and he just wanted to play with it. He said he went in there and changed his hard drive to an SSD drive, and he said that thing runs like a new machine now, just by changing to an SSD drive, because of how fast that drive is and throughput coming across it, which is something to consider about there. Then they talk about when you've got that network set up, how are you going to verify your connectivities? We've talked about that before, and that was with ping, which we saw back there in the ICMP chapter, and that we talked about it there. We mentioned extended ping also, which is available on different devices, different OSs. And with the extended ping, depending on which extended ping it is, you can do some different things with the ping command. The basic ping command, you're just going to a specific device from your device, and you're sending it pings a certain number of times by default, which normally is 4 or 5. I know Cisco uses one of those two numbers and Windows uses the other. They send out a number of pings. And I can't remember which one's which, okay? But 4 and 5 is their default one. With the extended ping, we can send as many pings as we want to send, and you can actually send an indefinite number on it. Guess what? I guess falls into DOS attacks to be used on that. But you can do a lot more pings to a device on it. You can also, on the Cisco ping, extended ping, you can ping from a different device than the one you're sitting on. So you can tell it. So he can be sitting there and tell it that he wants to do extended ping. He can tell it to ping from your machine to that machine while sitting at this machine. So we follow all that? Instead of the ping going from here to say to send it from there to there to see if there's connectivity between those two devices without him having to be there to use your device to determine. So we follow how that works. And that you're just giving it. And actually what you do is you just do ping, but don't give it any more information, and then it prompts you through all of how many of them you want to send and so on. And if you're going to send it from a different destination. Trace route, they mentioned about that one, that it's real good for verifying your connectivity. Actually, it goes beyond just verifying connectivity. It tells you how far are you getting in connectivity. How are you getting there? Trace route will tell you every router you touch on the way to the destination. Okay? And if they're not connected, you'll find out which routers did it get through, and that tells you where it died, and then you know where's the problem at of why you don't have connectivity. So you may well do ping first usually. Make sure you got connectivity and then turn around and do a trace route when ping failed to find out where it went. Or if it's taking really slow to get there, you may ping trace route it too to see on it, because it also gives you time to each router along the way. The trace route's a real neat and usable item there. Trace route also has an extended command to it available, particularly on the Cisco devices, that you can use also to do some other things with it. And that you can set it on what's the maximum distance it's going to try to go, so you can have it do further than the default what it wants to do of what normally things are sent at, which I believe is 30 hops is the default when you send things out by default, okay? And that on the extended trace route, you can tell it, keep on going longer than that, because if it's really wandering way off on it, you may be going, wait a minute, see what in the world's going on here. So they spend a good bit of time talking about that on there. Then they go in and talk about how you configure your Windows host and getting in there. They show you briefly on that. And they also, because you can go in and you can just look at it graphically, going through your network connections part on it, where you go in and set those settings if you need to. Or the second thing is you can use what I told you at the beginning of class, the ipconfig command. And you can use ipconfig. If you just do ipconfig, it's going to give you the IP address, the DNS address, the default gateway, and that's about all it gives you. If you do ipconfig/all, it will give you a whole lot more information about your connections. And it will tell you everything about your connections off your PC. And so then you can trace out problems on that. They tell you on a Linux host about how to do it also. Essentially, you're going to do the same thing as you do on a Windows host, except it's not ipconfig on a Linux machine, it's ifconfig that you will use, okay? And remember, Windows came from DOS. DOS actually came from Unix, which is where Linux came from also. And Unix had ifconfig, and that was one of the things that when they created DOS from it to make sure it was a different OS than Unix, they changed the ipconfig command, the ifconfig command to ipconfig. So just remember the IF and IP. On the Mac, using the Mac OS, it's ifconfig also, because that came off of the Unix approach also, and they used the Unix approach. And most of their commands on the Mac OS are actually the same as what you got on Unix and Linux. So it's a much more Linux-Unix approach. Then they mention ARP, which we mentioned way on back in the course, which will give you the, if you've got an IP address, it gives you the MAC address of the location. And you've also got an ARP table in there in your machine, remember, that keeps track of, only for a limited amount of time, and it clears them out, of IP addresses and the MAC address associated with them. And so you can look to see what's in the ARP table just by doing ARP-A, or you can actually go in and look to see what the MAC address is for a specific IP address, doing ARP and the IP address. And in that case, it's not going to just come from that table, but if it's not in that table, it's going to go out and start through the search process. Then they talk about the show commands on your Cisco devices, and the show commands are really handy for you. So show run config, or they've got it there as show running dash config. But you can do that just as show run, that you can abbreviate running dash config as run. So show run will tell you about all of your configuration of that machine, that of the configuration you are running right now. It may not have been saved. Okay. Show interfaces tells us about the status of all our interfaces and any error messages that are occurring on the interfaces. So you find out, are your interfaces up and running? Show IP interface gives us the layer 3 information on an interface. So that's going to give us the IP addresses and that type of stuff about each of the interfaces. Show ARP just pulls, just like we were just talking about on Windows a moment ago, of ARP-A, it pulls the same type thing. It shows you the ARP table. Show IP route will show you your routing table in your Cisco device. Show protocols tells us which protocols are operational, that are enabled, not disabled. Okay. And then show version tells us what version of iOS we're running. So then they go through and they show you those over several pages or down several screens. As I assume a couple of you, it looks like you're following along online. So now you got a bunch of codes right there showing to you that you can skip over that I just described to you real quick. And so they go through and show those. Show CDP neighbors command, and that's the command, show CDP space neighbors, is going to give us, because that's the Cisco Discovery Protocol, that will tell us the routers that are attached to the router you're on. Okay? And it will also actually give you information. If those routers have shared their information, it will tell you what routers the attached routers are connected to, and tell you whether they're directly connected or not. So that one's a really useful one at times on diagnosing things. So show CDP neighbors is a good way to find out what your network basically looks like as far as the routers are concerned. Show IP interface brief is just like we were just mentioned about show IP interface, but brief cuts down the amount of information it gives us and basically just tells us, is the protocol up and running and is the actual interface working? And the protocol up and running requires you have done the no shut to activate the interface. So it tells us that, and that you're always looking for yes and yes if you want it to be a working interface. Okay. If you're supposed to be using this interface and it doesn't say yes and yes, something's wrong with it. So it goes through and shows you each of your interfaces, tells us the IP address associated with them, and then tells us those two statuses on it, and gives us that. So with status being, is it actually physically working? And then protocol is the protocol work that goes to that interface. So that one can be really useful to you. They then talk about some troubleshooting techniques, and they talk about a 6-step process here to do basic troubleshooting. So if you've got problems on your network, what are you going to do about it? The first step is to identify the problem, to go in and figure out exactly what the problem is, and get them to tell you exactly what is going on, and for you to figure out what is the problem. You may not even do anything in this step, usually not on the devices. You're just getting them to tell you on that. Step 2, now that you have a full understanding of what the problem is, or at least you think you do, because depending on who it is, the user and stuff, and as you're looking at stuff, you may or may not. Step 2 is establish a theory on the probable cause. So then you're going to sit there. But first, make sure you got a clear understanding of what's going on. So ask questions and figure that out. And then take your guess, which is what step 2 is, about what's wrong. And that's the approach you're going to then use. But you've now got an idea of what's wrong with it. 3, test your theory to determine the cause. So now do things that are going to see if that is what you think the cause, that really is the cause. So you've sat there, listened to the person, and they told you all about what's going on, and you go, I think their network cable is disconnected. Okay? So then at that point, you can do one of 2 things to test it. Get them to pull out the computer, or you pull out the computer and look and see if it's plugged in the back of it. Or 2, to do your ping to 127.0.0.1 and see, does it actually connect to it? Or to ping to the IP address that's supposed to be associated with that machine. And see what happens. Then establish, once you've figured out where the problem is, maybe in that case you have figured out it is unplugged. So then establish a plan of action and implement the solution. So what would we do in that case? Either you tell them to plug it back in or you plug it back in for them, okay? And then you'll test that, so you're going to verify it in step 5. And it says implement preventative measures. That could be telling them don't pull a cable out, okay? Or it may be where you now secure off certain areas to keep it from happening again, because you don't want it to keep on happening. So but first, make sure it really works. So test it in several ways. So if it was that cable was unplugged, once they plug the cable back in, make sure they can get on the internet now and have them check with several different websites, and that then you know you got it working. Don't just plug the cable in and go, okay, I fixed it, and walk away. And that may or may not have been really the problem. That the cable may have gotten unplugged, or somebody unplugged it. Is their attempt to figure out where the problem was, and the problem's somewhere else. And then 6 is document what you did. Write it down, so that then when you run into a similar problem in the future, you can look at that to remember how to fix this problem you had. Number 2, you've got documentation on something you fixed and how you fixed it. So then when somebody wonders if you're really worth keeping around of what they're paying you, you can show them, here's what I've been doing. So that documentation becomes important. Resolve or escalate, that's a question of when you're working on these and fixing the different problems that occur in the little tiny organization. That's probably not a question that you would ever encounter, because you may be the single IT person. So the question of, do you resolve it or do you escalate it to a higher level would be, all right, I resolve it, so I go take care of it. Escalate it to a higher level, okay, I gotta go take care of it, because you're the higher level too, okay? So, but in a larger organization, you may well have layers of support, and that when you can't figure that one out, or your basic checking, trying to determine the problem didn't work, then pass it on to somebody that theoretically knows more on it. The debug command, they mentioned about that one. Nice thing about the debug command is the debug command gives you lots of details of everything that's going on. Bad part about the debug command is it gives lots of details about everything that's going on, that you will get overwhelmed by the information you get when you run debug. So you don't want to normally run debug unless you want all the details of everything that happens. It is a good command. Is everybody following that? But don't try running it all the time. You're going to overwhelm the amount of information you have there, fill up your logs and everything else. If you want to turn off debug, the easiest one that they've always taught in the past was to do no debug, which is just like other commands in the Cisco iOS. If you don't want that command any longer, just do no on it. Second thing is you can also turn it off by doing undebug, and that will stop debugging. I'm not real sure about it. Terminal monitor is where you are logging into another device, and sort of like what we mentioned about the remote desktop connection, which actually gives you a whole lot more, obviously. But terminal monitor lets you get into the device on a command line interface. Okay, and that you use Telnet probably to do that. That's one place where you may well use Telnet to do it, because you're not really doing secure on that when you're just trying to fix things. Or you could use SSH, okay, to make it a secure connection and go across and get into it. And you can also use terminal monitor or the thing to use in there also on. They then go through on these last few pages talking about a couple of different type things could go wrong and causes problems. The first one they mention is about duplex operation, and that depends on the devices you're using whether that could be an issue or not. A lot of devices now it's not an issue when you're on them, but if you have older devices that do not automatically set the duplex on it, which would be half duplex or full duplex, and remember it's a question of can you send information both ways across the cable or just one way at a time across it. Most of the stuff is now moving to full duplex now. Because if you're using 100 megabit speeds or faster on your network, you got to use full duplex. Actually at 100 you can use that on that one, but strongly encourage you to use 100. And if you go to a gigabit speed for your network, you've got to be full duplex. So everybody follow that? So if you had half duplex, it's definitely going to slow it down. And if one of the devices is half duplex and the other is full duplex, it's got to be a half duplex connection. And so the people that are using the full duplex connection may be going, it's going really, really slow. Well, the reason is it's not taking advantage of their equipment. So that one's not that big of a problem anymore. That used to be a big problem. But now, since we've moved to most networks, almost every network you get into today is going to be at least 100 megabits, if not 1,000. What you're using right in here is 1,000. Okay? It's got to be full. You could go into some older organizations, some organizations that have not upgraded their equipment in many years, and they may be running 10 and running half duplex. If that's the case where they're having problems with it now and they're running those speeds, my suggestion to them would be buy new switches to hook the whole thing up. Replace their switch devices, which may well be their router devices too, okay? Combined. Replace that, and most likely their PCs that they're connecting to it are actually running the higher speeds, because most of the time what you're going to find is people will upgrade their PCs, but they never upgrade their networking equipment until it fails. And so you will find some older networking equipment out there. Just like when we talked about switches initially, I told you that there also used to be hubs on that layer. Now hubs are actually still associated with it, but you should not be using a hub in a network. Now you will use other hubs. You may well have a USB hub to connect a number of USB devices together That is done still with hubs. So there are hubs for other things, but for the network, should be on switches. And if they have a hub running, if you will just get them to buy a new switch to replace that hub and not even bother to program the switch, just use it in basic configuration setup, they will be impressed with their speed pickup. Okay? That'll get rid of your problem of half duplex, full duplex too. Addressing issues, they talk about them on iOS devices. And actually, I just talked about that on you for one thing, because if their addressing's messed up on there, that on the show IP interface brief, and that can actually be show IP INT brief, it would show the protocol is down, okay, if you have the wrong addressing on it. And where they can match between what it connects to. Then they mention about IP addressing issues on end devices, and about where you can go in, and we talked about that already too, because I mentioned about what IP config will give you. And so if you're having an issue on that, first thing I would do, for instance, my office machine over at Walker, first of this week, well, I guess Monday and Tuesday it must have been, that it popped up and gave me a message and said that the IP address I was using was a duplicate use address. There was another device on the network using the same IP address. That's happened a couple of times before. At some point, I think they've got a device somewhere on the network that has got a built-in address that only gets turned on occasionally. And it turned up for 2 days on me. And their suggestion was to do what I mentioned about my article this week, and that was do an IP config / release and an IP config / redo. Well, I did IP config before I did those commands, which I would suggest you do too, because it will tell you what the address is right now. And then when you do it, and then you can see when you do renew, it will tell you what the new address is. And actually in both cases, it renewed as the same address that it may have in the process of sending out, but this is the address it was going to give to me, which may well be assigned in their table. I don't know. It may have told the other machine it's got to quit using that address. I don't know. But IP config will give you your information about how they're set up, and you may have a problem, particularly when you have people learn something about how addressing works in there, that they've seen or heard something on that people will go in and change the address on the machine because they think if they use this address that was in the little thing they were reading or watching, that they'll get a whole lot faster response, and they go and duplicate an address used somewhere else. And so when you do your IP config, you'll discover what that it's not addressing like it should have. DNS issues. Big place that DNS issues will occur on you is people will tell you that they cannot get to web pages. So they'll tell you the internet is down, and that when you do a check, you determine the internet is up and working, that the connection is working to the internet, that you check your modem router. It's really a router, but most people are calling it a modem. It connects you out, and everything's working on it. If DNS is failing somewhere along the way, and sometimes you'll see this happen, and particularly on ISPs, sometimes they lose their DNS server, and then lo and behold, people will start calling in about the internet's down. Well, in truth, if the DNS server's down, you can't get to anything by domain name anymore, because with the DNS server down, there is no linkage between IP addresses and DNS names. But if you were to use the actual IP address of whatever machine it was you were trying to connect to, you could still get it. So everything's traveling across, it's just you can get it converted to an IP address. So again, IP config will give you information on where it sees the DNS server is that it's supposed to report to. Another one for you to realize is that beyond whatever DNS server your ISP tells you to put in there in the DNS settings, or that it has automatically appear in there, you may want to, and when you hit this, you may well want to put in there as a secondary DNS server. Google has several DNS servers available out there, which if I'm remembering correct, one of them is 8888, that's 4 8s. Another one's 8448, and another one's 4444, if I remember the numbers off correctly. And theirs tends to stay up always, and it's a public DNS server, those servers, and that you can actually use them on it. So, and that's what I've done sometimes. And if it's an issue of your ISP's DNS server's gone down, if you've got that in as an alternative one, everything keeps on working for you. Everybody else you know that's using Comcast or whatever that it is that the group of y'all are using, they're going to be sitting there telling you that their internet's not working y'all, where you're sitting there doing it. So you go through several things on that, and that takes us through the chapter. So you see where what I said at the beginning, most of what we did just went through in that whole chapter, we talked about at different points during the course. Okay? But we talked about the DNS stuff back earlier. In a previous chapter, we talked about IP addressing. In another, we talked about IP config at some point and so on. Okay, so they're just putting it all together here. And your assignment on this one should be more for your building. Okay? And if y'all haven't been able to do the cabling one, that if we, my online section of this class, because they can't come in, they're not supposed to come into the school. They can come in, but I'm not supposed to have a group of them and trying to work with a number of them that the school would rather not be requesting to come in, and some of them don't want to come in still. They're having to do an assignment for their lab final where they actually do in packet tracer. They're going to grab all the pieces of equipment in there and then build the whole thing together on it. And your assignment actually is similar to what you got to do in chapter 17. Okay? Although they take you through and give you complete directions on what you're doing. So it's not build this network and they give you an illustration and tell you, they're going to tell you exactly what to do on it. And even in those other students' case, it tells them what to do too, but they got to go through and do it. Which should make you feel more comfortable and that you really do know something about how to work with networks then. Now, remember the other part on this class, this is just the first of 3 Cisco classes you teach here at the college, which leads to where you're actually prepared to take the CCNA exam. I didn't say pass it. You should have a good chance at passing it, but we're not going to guarantee you pass it. We've gone over the material that's on it. It's a question of do you know you can use it correctly. Okay. I have been told that the new CCNA, which your curriculum is written for, that came out a year ago, that it is a whole lot easier than the old one. I know the old ones, several of them on back, were exceedingly hard. But I have been told by a couple of people that have taken the new one that they said it made it really easy. That it's a whole lot easier, that it is just a step above Network Plus. Cisco used to have a CCENT certification and CCNA and CCENT pretty much correspond to this first course. The other one is Network Plus. You've learned in this course all of the stuff that's covered on Network Plus. You've learned beyond what's covered on Network Plus. So if you're looking at certification, you should be qualified on this, but I would encourage you to take practice tests before you did that. If you want to do this Network Plus exam, get a hold of me about you buying a voucher through me, and I can get it for about 50% off. Okay. CCNA, they give, if you took Cisco 3, which is 2453, when you finish that one, if you make at least a 70 on the final exam, they give you a voucher for about 50% off from Cisco 4. Likewise, after y'all finish the class, and I mark out there at Cisco that you have succeeded, and it won't let you mark it unless you've met those mandatory things, then it will make available for you that you can actually get at Netacad, and I will send you this also, that you will get a certificate of completion. It's not a certification, it's a certificate of completion that shows you took the class, okay, which is a little certificate. The packet tracer class y'all are supposed to also do. When you complete it, you did the course feedback, and I think it's one test in it, wasn't it, that you had to do? And if you haven't finished that, you need to get that done as quickly as possible. Okay, and I've got transfer grades on that again, but it's been about 3 weeks since I transferred last. Because that's an assignment for you in here also, okay? Once you do those 2 items in there, it will actually, if you go up there and look in where your name is on the top of the page in Netacad, drop down on it, it actually has a link there for certificates and something else or something on it. It will give you the PDF file for your certificate for the packet tracer file of completion, okay? The other one is, if you make at least a 70 on the final exam, you also get a letter of congratulations for doing well in the class from the CEO of Cisco, and that'll be available in that same spot. But the other one is, somewhere within the next couple of weeks after we finish the semester, I will pull down the entire set of certificates and letters, all of the PDF files for those from Cisco from the class, and I will email out to each one of you certificates and letters that you qualified for, okay? So some of you may just get a certificate for this class. Some of you may, if you did the packet tracer one, you'll get a certificate for that one also. And if you made at least 70 on the final exam, that you'll get the letter also when I send those out. But it takes a little bit of time when I go to send them all out, because pulling them down is quick and simple. I just have to go out there and click a box to say I want a copy of all of the certificates and letters. Then it sends them all to me as a zip file, so then I got to unzip it, and then I just got to go through, click on email, obviously in Blackboard, and then attach whichever files it is there. But I got to go find each one of those on my machine. Obviously, they're all in the same folder, but you can see that does take a little bit of time on it. It's not something that I just go in and click the check a box and it proceeds to send them all out to all of them. But they are available to you too. Here's my suggestion to you. Take those PDF files and store them somewhere on your computer where you remember. Print them out also. And if you go looking for a job related to computers, take them with you. Okay? That's a portfolio. Because they show you've done something. You follow on that? But I would save those PDF files also somewhere on your machine, so that if you want them again later. The other part is, it will give you a choice of when you go to print it, of if you want it to just say Cisco for the instructor, or that you want it to print with my name down there. And it's got a signature block for me, actually a signature line for me to sign on. And if you want to do that with it, then print it out, and if you'll get a hold of me, if you can bring it to me over at Walker or whatever, or actually I can probably print it out for you, but it'll be on regular paper and mail it to you. But if you bring it to me at that point, then later on, that you can get me to sign it. You just contact me about getting me to sign on it if you want my signature on it. I'll be glad to sign it. Okay. And like I say, I can do also, if you want me to print it, that I can print it on a piece of paper and sign it, print and sign it, and mail it to you also. That way you can sign it. But if I do that, I'm going to print it on regular paper for your phone, or you might want to print it on the better quality paper and then get me to sign on that one on better quality paper. And then I'll be glad to do that. And if there's several of you and that you go, can you just come over here and meet us here at this campus one day at a certain time? I can arrange to do that also. Come over for several of you. Sign, sign, sign. And for that matter, you really could forge my signature. Because the fact you got the certificate, you know it was fully on that, and you could sort of just put something there if you want it. Probably not the best thing to do, but nobody's going to know really on that anyway. And for that, I'm not going to be worried about it. Just remember, however you use that signature there or claim to be mine, don't think you can go to the bank and borrow $100,000 and have me have to pay it back because you put my signature on there. No, that doesn't look anything like my signature, and I didn't sign that. And then you're stuck. All right, any questions on all of that? We're getting close to 9:45, so we're near the end of the full time. So again, next week and the following Monday, we're going to do lab time. Okay? That y'all can work on cables. Just remember on the cables, if you have not completed all three of them from the midterm one, you've got to get all three of those completed and be graded off on them, and then you can work on building the ones for your final exam. The ones for the final, you don't get to ask questions or use the internet to look it up on, but you can bring written notes on it if you want. I will also leave that on the board for you up there. That's why I haven't erased it all along, apparently. I'm guessing that West is thinking the same thing on it, that since I left it there, that's important to me and that there's no reason to erase it, that we want y'all to know that on it. Because you don't have to really remember the colors completely, because you can use a piece of paper with that anywhere you're out. If you're out building them for somebody or whatever, or you can look it up on the internet to find them. But you definitely need to know how to put it all together and get a good connection. Okay, so everybody follow that part? Any questions on what we're doing for the rest of the semester? And then your final exam, remember, is due Tuesday a week, and it'll be available that Saturday before. I'll have it, should have it available from 12:01 a.m. May the 1st until 11:59 on May the 4th. I have not gone out yet to start activating that one, but I can now. I can't, even though I'm setting dates for them to start later, I can't do that all the way through the semester. At the beginning of the semester, that I've learned one thing. When we change times, Cisco, when I used to try to do that, when we changed times, Cisco would then goof up on what in the world were the times that tests were activated for. It didn't just go over smoothly from daylight to standard or standard to daylight. So I quit doing that and only do them a few days in advance before the test. So like test that you got to take next week, I have not activated it yet. I will activate it, should activate it tomorrow. Everything that had been turned in through Monday night is graded at this point. Now, I have not moved everything back and forth between the two systems. I did that up through a couple of weeks ago, and I need to work on that again, and then may well work on that some this afternoon. But first, I got to finish my unit from last week on AWS. So of course, I'm taking from them Solution Architect. And I think think that's all I've got on it, is I've got this one lab to finish and take the test for the tech. And then I'm gonna work on that some this afternoon. Likewise, I have not put Tuesday's lecture out on the internet either. And I'll probably do that this afternoon or this evening also. Just didn't. Really didn't do anything with this. I was gonna say I didn't do anything with the school last night, but that's not true. Because I did answer one student's email, the only one I got. And then Ms. West and I corresponded back and forth on a couple of things that we were emailing back and forth for a little while. So I am going to kill the recording.